Gents, let's have a look at I'll have a look at these problems. We haven't looked at any yet with any of the other functions in. So these two are a cosine function to integrate and a sine function to integrate, and they've both got a constant in there as well. Okay, so looking at the table of integrals, what is the integral of sine AX? That's minus 1 over A cos AX plus C. Yep. And the integral of cos AX is, from the table, 1 over A sine AX plus C. So you're going to use those two entries in the table of derivatives to work on those two functions. I'll get them written a little neater on the other page and paste them into that page, I think. So now we've integrated functions to obtain an indefinite integral that includes a constant of integration. That can only be found if more information about a function is known. Definite integrals are integrals that have had limits applied. For example, if we want to know the value of the integral of x squared as x increases between 1 and 3, there are limits. You'd write that definite integral like that. The integral sign with the lower limit at the bottom and the upper limit at the top. What you're saying is, we're interested in the integral of x squared for values of x between 1 and 3.
Would that be the same if you had x cubed?
You'd be then interested in the value of the integral between the values where x is 1 and x is 3. That would be the integral of x cubed instead of the integral of x squared. Okay? Well, let me just move that over a bit. What does the shape of the graph y equals x squared look like? What does a quadratic equation graph looks like? A parabola, yeah? Okay. Is this a parabola opening upwards or downwards? Yeah, if we was to graph this, that would look something like 0 squared is 0, so that's gonna cross the x-axis here. That's gonna look something like that. Yeah. What we're saying when we talk about that integral, the integral is effectively the sum of all the values between those two limits. So we're looking at the limits where x is 1 and x is 3. I don't want to preempt what we're doing next week, but effectively, if we find the value of the integral between 1 and 3 of x squared, we'd find out what the area is under that graph there. That's what the integral means. It's the sum of all the values between those limits. One of the uses of integrals is to find the area underneath or between underneath the graph and the x-axis, or between two graphs. Yep. Okay. Yes, you're gonna, in the longer answer question, there'll be something around the uses of integrals. Alright? So for instance, if you've got, remember in differentiation we talked about, if you know the rate of change, you've got speed, velocity, you've got velocity and acceleration and change of position, you differentiate. If you've got a graph of speed against time, you integrate that, the area under that graph is the distance travelled. So if you've gone at a speed of that shape, and you want to know the difference travelled between x is equal to 1 and 3, you integrate between those, and that gives you the distance travelled. Yeah, okay? So, but more about that next week. At the moment, we're interested in the mechanics of how we evaluate definite integrals. So how do we do this then? Evaluating a definite integral. So we're going to look at this x squared one. What we do is first we integrate the function, and it's common to put that integration into the curly brackets, but it doesn't really matter what shape of brackets you use. Okay, so we integrate it, put the result into some brackets, and put the limits on the outside, like I've done there and there. So you're all capable of integrating x squared. We add 1 to the index and divide by it. So we got x cubed over 3, and we got a constant of integration. Then we can say the value of that between 1 and 3 is equal to its value when x is 3, take away its value when x is 1. Yeah? Okay, so what you then look at is putting in here x equals 3, sorry. So we got 3 cubed over 3 plus c, and in here we replace x with the lower limit, 1 cubed over 3 plus c, and then we evaluate each of these. So that bit is 3 cubed, 3 is 27, 27 over 3 is 9, plus the constant. Let's evaluate 1 cubed is 1 over 3, so that's a third plus c. And then we bring all the like terms together. And if you look here, you've got 9 minus a third is 8 2/3, and c minus c is nothing. The constants disappear. Alright, Dom? Alright? So, in actual fact, now we know that the constants will always disappear, we can actually not even bother to write them in this stage. We can forget them. Don't bother to write the constants in, leave them out because they cancel out anyway. Okay? And I'll put that note on there. Note, when definite integrals are evaluated, the constants always cancel, and so it's usual just to leave them out. You mustn't leave them out of indefinite integrals, but you can leave them out when you're evaluating definite integrals. So, those two. Let's have a go. So, we'll have a go at the first one together. We've got the integral between 1 and 2 of 3x dx. So when we integrate that, what do we end up with when we integrate 3x? want some curly brackets. Three x to the, we don't take one off, do we? To the 2. 3x squared over 2. Don't need to write c between 1 and 2. Right? So we've just integrated it. Forgot about the constant of integration because we don't need it. Put it in curly brackets and added the limits on the end. And then what we've got to do is say that's equal to the value of 3x squared over 2 when x is 2. Take away the value of 3x squared over 2 when x is 1. Yep. Then we substitute the limits for x in each of those. So until you get used to it, it's probably best to write it out in full. This one is 3 times 2 squared over 2 minus 3 times 1 squared over 2. And evaluate each of those with your calculator. 2 squared is 4, times 3 is 12, divided by 2 is 6. Everyone agree? Got to square first, remember. Got to do the square one first. Yeah, order of precedence.
3 times 2.
You've got to do 2 squared, 4, and then multiply it by 3. Yeah, 4 threes are 12. 12 divided by 2 is 6. 1 squared is 1, so that's minus 3 over 2, and the answer is 6 minus 1.5, 4.5. Everyone agree with that? Have a go at the second one on the page then. So what we got to do to that one to integrate, we got to separate it. Yep. The integral of the constant 4 is so there's my curly brackets. Integral of the constant 4 is, if we integrate the constant 4, what do we get? 4x minus, if we integrate x squared, we get, it's going to involve x, add 1 to the index, divide by the new index. Close the brackets, put the limits in. use square ones if you like, I don't care. Not normally, don't use round ones for these, use square ones then, because you may well want to use round ones inside the brackets. So use square ones if you want to. The convention is to use curly ones in most textbooks, but square ones will be fine.
Difference then between square brackets?
Nothing, no difference at all. Just use the different types to distinguish between pairs, normally. By convention, if you read most textbooks, they use curly brackets for definite integrals. But by all means, use square ones if you want. Right? So then we substitute in limits for x. So we got is equal to 4 times 3 minus 3 cubed over 3, close the brackets, minus 4 times minus 2 minus 2 cubed, be careful with that in your calculator, over 3. Close the brackets. And then you evaluate each of those. And what do you get? That bit is 12. 27 over 3 is 9. Minus 4 times minus 2 is take away minus 2 all squared, cube, sorry, minus 8 over 3. Three minus what? Final answer? Huh? Which is 8 1/3. Isn't it, Dom? Okay? So you got the method. Please be aware, when you're doing work with integrals and limits and cosine functions, we're talking about the limits being in radians. So calculators go in radian mode. Alright? So I'm asking you now to evaluate between 2 and 1, definite integral, 4 cos 3t dt. And, because I'm a nice guy, that's the entry in the table for...
You have little reminders in the exam.
What?
Just like for your calculator.
No, that will be... No, I won't be no reminder for your calculator, no. And you'll lose marks if you don't put your calculator in there. Right, guys. It's go through these. A. The integral between 2 and 1 of 4e to the 2x. If we integrate e to the 2x, we get 1 over 2 e to the 2x and we got to multiply that by 4, the constant. 4 times a half is 2, so that's 2e to the 2x plus c if we were doing an indefinite integral, but we know we can forget that, and we want to evaluate that between x is equal to 1 and 2. Yeah. So it equals 2 times e to the 4 minus 2 times e to the 2. And the answer to that, gentlemen, is 94.41. Yep. There or thereabouts. I'm probably guys, I'll probably be say to 4 significant figures or 5 significant figures. If I don't, 3 to 4 is about a reasonable answer that you should have given me to if it is a decimal. Alright? Should be bearing in mind how many decimal places there are in your data really, or how many significant figures there is in your data in the first place. Alright? And then the second one, we've got integral between 4 and 1 of 3 over 4u du. That can be written as 3/4 outside the integral, 4 and 1 of 1 over u du. Because another way to write that is 3/4 times 1 over u. Now we've got that looking like that, we've got an entry in the table for it. Yep. Which is that one, the bottom one there. Just move that down the bottom of the board. Put that one in there. Okay, so now we can write out this integral. The integral of 1 over u is ln u, and then we've got to multiply it by 3/4, and we're interested in that between the limits of 4 and 1. Agreed? So that's 3/4 of ln 4 minus 3/4 of ln 1 equals 1.0397. Okay. So you can do the integration, definite integrals, not, it's just applying that and substituting in the limits. Probably because you're ending up with a number as an answer rather than another function. Yeah. And ultimately, that's what we want to do. We want to find this perhaps this summation or this area under a particular graph. All right?